part 3 of 3, I promise. And this one, there's only like 6 slides. Yeah, not too bad. All right, so we were talking about niches or niches. And now what we're going to do is we are going to specify that there's 2 types. There's generalists and there are specialists. So generalist species are ones that really can live in a wide variety of conditions. They are able to use different resources. They are easily adapted to changes more so than others. These are what we call those R strategists. Again, think rat, roach. Think organisms that can make it even when the bomb goes off. Creatures that can live in the depths of the ocean. Creatures that produce lots and lots of babies, and they also tend to just will eat whatever and whenever, right? They're not selective at all. Then we also have what we call specialists. Specialists are they're much more narrower, and so they have very specific range of requirements. They are very high maintenance in that realm, if you think about it. They have to have very specific environmental conditions. Fish, thinking about how much salt is in the water, the salinity, or the water quality. Some fish are extremely sensitive, as well as other organisms that live in the water. So they would exist in what we call as a specialist species. It's not that they're weaker. Don't think of it as that. It's just that they have adapted to live under very specific circumstances, and they only thrive in that tiny little narrow niche of which they have evolved. And those are what we call the K strategists. K meaning think more like kangaroo, kangaroo rat, animals that tend to they have to eat a very specific diet, or they have just really, really fine requirements that they have to fit. Most organisms are not going just to fall within one or the other. A lot of them will overlap. Say for humans, if you think about us, we are generalists in some ways, but not in others. We can eat a lot of different things, but we can't live in a lot of different places, not without our own ability to make clothing and that kind of stuff. All right, environmental changes. Plate tectonics, we will talk about this in an upcoming unit, and we're going to talk a little bit about geology and stuff then. But basically, we started off with Pangea, and the plates broke apart and have been shifting ever since. That has really created an allowance for some species to move, but then also some species to be isolated. And so it's that has really been able to propagate certain species and not others. Think about, have you ever heard of the term New World apes and Old World apes? And I don't mean ape environmental science, I mean like apes. Well, New World apes are ones that are found in Central and South America. Old World apes are ones that are found in Africa. And the reason why is because they are different from each other, and they believe that as the two continents drifted apart, they have evolved separately. Here you can see there's, this is a good picture where it shows you where fossil evidence shows how there's really awesome evidence of fossils existing in overlapping between continents, but now that these continents are far apart, you wouldn't think, hey, I found the fossil remains of Crinonathus here in South America, but then also in this part of Africa. Kind of goes back to the Old World, New World apes concept as well. You can also see, my favorite, I think, is the plant, because this plant, this fern, was found in so many different realms and regions. It's, again, great evidence on how, as to how the continents were placed closer together long time ago. This picture down here also shows how ice has changed, and it's continuing to change even faster. I would say modern day, yeah, it's not even that. Examples of this would be very sudden explosive events, natural disasters like volcanic eruptions, massive earthquakes, but then those create change instantly, in that there's a major event that happens in a very short amount of time and everything has to adapt and adjust to that. But then there's also extremely slow things like climate change, the melting of the ice caps, and those kinds of phenomena where organisms have a lot more time to adapt, but it's not necessarily, it's a race. It's still a race. Here are a few more terms that you might see that you need to be privy to. Divergence means when one species becomes two. Convergence is referring to the fact that you have two completely different species and they either start to mimic each other or they become closely enough related where they can even interbreed, or there's a couple of other interesting examples out there as well. You guys know what extinction means, but did you know that almost over 99% of all the species that have ever lived, and that means from day one of all living things, are now extinct? It seems ludicrous, but if you think about how long the planet has existed with living things on it, it totally makes sense. All right, so endemic species are ones that are only found in a very small specific area. And for example, endemic species here in Texas would be like there's a blind salamander that lives in specific caves and aquifer regions, and so that would be considered endemic because it's only found there, and it is actually very it's close to extinction. It's kind of a serious situation. Background extinction is where you have normal extinctions occurring in nature. Mass extinctions are ones where you have a large percent of species lost that goes extinct within a realm of time. And you can see here, as of right now, they believe that we have undergone 5 mass extinctions. 1, 2, and this is kind of trickle effect after the fact, 3, 4, and 5. All right, and they believe that we're actually on the verge of the 6th. So in summary, Earth's biodiversity it's really complex. It's extremely complicated, but in very typically slow moving process that adapts and allows for change over time. Evolution below the species level is of like microevolution. We talked about this a little bit. So microevolution is where you see a specific change in a shorter amount of time or in something that we can do like artificially choosing specific traits. Genetic changes that create new species, then that is what we call macroevolution, macro meaning larger. And extinction and speciation are what lead to biodiversity. Now, that doesn't mean if we allow extinction of multiple species to occur in a short amount of time, that doesn't mean that that's going to necessarily lead to biodiversity immediately. It's just that that's going to open up specific niches for other organisms to adapt into or new species to evolve. And again, very slow process. All right, so that is it for the Chapter 5 mini lectures. If you have any questions, always just send Ms. Cobb an email or a reminder.